This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
As we already saw it, when we divide this number by 10, eventually we are going to have a 0. So we divide it by 10. If it's not 0, if we can divide it by 10, we increase the number of digits by 1, by 2, by 3. And eventually we have 0 here as a result. The number of digits is 3. We have 0 here. And if this number is 0, we are basically stopping. So one of the algorithms that we can apply is the following.
How do you remove digits?
Very simple. I mean, if I have 375, how can I remove this 5? If I divide it by 10, then I have 37. Then this 37 is going to be divided by 10, and I have 3. Then this 3 is going to be divided by 10, and I have 0. If I have 0, I stop. So I've divided it 1, 2, 3 times, okay? Meaning that I have 3 digits. Each division takes out 1 digit from the number. So while this number, okay, the function is called digit count. It should return the number of digits, so it's an integer. It takes this number as a parameter. Initially, digits are 0. So while this number is not equal to 0, what I'm doing, this is one of the ways you can do it. I mean, you can think another way, tons of ways. What I'm doing is the following: number is equal to number divided by 10, and since we're dealing with integer numbers, we don't have a floating point part here, and I'm incrementing the digits by 1, so digits plus plus. Okay, if I can do it, and I'm doing it. So let me run the program. Cin ignore, cin get, and I'm running it. Please enter a number. Let's say I'm entering 357. 357 has 3 digits. Is it working? Let me run it again. It should be 4. Yeah. It has 4 digits. But what if I give us 0 as an input? 0 has 0 digits. Is this true? No. So the function is not working properly. What should we do here in that case? If I give 1 as an input, then 1 has 1 digit. Okay, it's working. But 0, it was not working. Because this file says if the number is not equal to 0, then divide it and increase the number of digits. Basically, with each loop, we are taking 1 digit and increasing the number of digits. Okay? But if it's 0, if this number is 0, it's not working. So what should we do here? What about this stuff? If none is equal to 0, then what? Then return 1. This is it. Or you can do if, intentionally I'm doing this stuff here. If the number that we're sending as a parameter is 0, then I'm returning 1. Now the function always finishes when I'm returning 1. We might have here millions of lines of code, hundreds of lines of code, but when we have returned, the function finishes, because this is what we want from the function. So if the number is 0, I'm just returning 1, meaning that I have 1 digit, and I'm finished. We're not even checking this while. It's going to be false, by the way, but we're not even checking or bothering with that, okay? Maybe it's not a polite way of doing things, but you should remember that whenever you return something, the function is finished. So pay attention to this stuff, okay? Usually, not always, but usually the best way is to use only one return, and that return should be in the end. If you use it there, it's okay in this case. But sometimes the functions are very messy, very hard, and you cannot follow them. And you might return something without wanting to return. So try to put return as late as you can. I mean, if you can afford it to put it here, then do it. That's why I'm going to change the code. Although it's not wrong, I'm not going to return it now. I'm going to say that digits is equal to digits plus 1. I'm going just to increment it. Now, if the number is 0, 0 is not equal to 0. This is not true. So I'm not going to execute this part here at all. And I'm returning digits, which is 1. Okay, this is it. Any questions about this easy function and easy example? If there are no questions, let me go with another example. Should I play the role of the compiler? Meaning, should I draw on board how it's working or not? No. If this is clear, I mean, please, if you think that I should draw it or explain it step by step, just raise your hand and I'm going to do it. It's extremely important to understand how the loop is working, because we're going to have harder and harder examples. Okay? So no questions? No requests? Okay, I'm removing this guy. Now let's go with another example, which is called atoi. Add existing item atoi CPP. Now, you will have an important library, and probably you are going to use this in advanced programming as well, not only here. That's when with atoi you are going to include, so add existing item, string utilities, the header, and string utilities CPP, both of them, include them. Usually we put the header here, but it's not important for the time being. Now let's see what the header is doing, what the string utilities are doing. This library has a couple of functions, few functions. Those are the following ones. I'm going to tell the most important ones. It's not a class, it's only a header, meaning that it has only some functions defined. One of the functions that we are going to use, pay attention, is toLower. You can see in the comment what it's doing. toLower takes a reference of string, returns nothing, and toLower, what the toLower is doing is converting all of the characters of the string S to lowercase. What does that mean? If I have something like this, capital A, A-R, T-R-I-M, if this is the string S, then what I'm doing, I'm passing this as a reference, and all the letters that are inside it are going to be lowercase. S, after calling the function, is going to be like this. Maybe we should record this one. Okay, so again, if I have a string S, it's like this. A, T, and R are uppercase. And I send this as a parameter to the toLower function. When the function finishes, the string is going to be like this. It's changed, basically, okay? We have another function. It's called toUpper, which is doing the opposite thing. If I send the string S, all the letters are going to be capital, uppercase, after the function finishes. So the string is going to be changed. That's why we pass it as a reference. We have another function which is called strip punctuation, and you see we have precondition and postcondition. Postcondition means what will happen when the function is going to be finished. Okay. So with this function, when the function finishes, after sending S, we don't have any leading or trailing punctuation, because you might have a string and you have like multiple punctuations in the end, full stop, semicolon, blah blah blah. it's going to be removed by this function. Strip white, no leading or trailing white. You might have a lot of white spaces in the end, in the beginning, in the end. If you call the function, the string, this function is going to remove those from the string. Then we have lower string. Lower string is basically doing the same thing as toLower, but there's a difference. Can you tell me what's the difference? You see, we are returning a string here, and I'm not returning anything in the toLower function. But here I'm returning a string. Yeah, it returns the lowercase case equivalent of s, of this string s. But why we should write the same thing twice? There is a difference, of course, because in the first case, in toLower, in this function here, the string s is changed. But here, you see, I'm sending it as a reference, but I have a constant here. This constant prevents us from changing the string, but instead we return a lowercase equivalent of this string s, okay? So if we had the previous case we saw with Artrim, we're going to return Artrim as a string, all in lowercase, and the initial string, the string that is sent as a parameter, is not going to be changed. The same applies for upper string, okay? I mean, you can see the definitions, but how it's done, but I'm not going to be engaged in that stuff because it will take a lot of time to us. Other functions are the following, which are the most important. This one, atoi, returns integer equivalent. So we are taking a string and we are returning an integer. So what you said previously, how can we convert string to integer? We're going to use this function, okay? But there should be a precondition. This string should be consisted of characters that are digits, okay? Like 3, 4, 7, 8, 9, blah, blah, blah. All of them should be digits. If they're all digits, then we can convert this string to an integer value. Otherwise, if I put A, C, F, W, whatever, I cannot convert it, okay? So this is the condition that I should have for this S. There's something opposite, itoa, okay? Integer to A, to string. I'm taking an integer and converting it to string. There's another function, toString, which is basically doing the same as itoa. Those are exactly the same. I think this toString is calling itoa. But this toString is used more in C#. You'll see it. That's why we're using toString. So if you take an integer, call the function toString, you give it as a parameter the integer, it's going to return the string. The same applies for double. You're returning the string equivalent of the double D. You're kind of converting from one type to another type. This was the header, and you're going to deal with this header a lot. You're going to use it for your homework. In string utility, CPP is the implementation of the functions that we saw. So this is how toLower is implemented. It's short, toUpper, upper string, blah, 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 and so on. But we don't have time to deal with them. Maybe you can check it at your home. No, you don't. You should know only how they work, what they do. Then call them, use them. That's it. You don't need to know that. Okay. Let's see what this function is doing, this program is doing. We are entering string of numbers separated by semicolon, and we should find the sum of them. Namely, we have 25, which is one number, semicolon. Again, let's say 15, semicolon. Let's say 3, and this is it. I want to stop here. How many numbers do we have? 3. And what's the sum of those numbers? It's 43. 25 and 15. 40 plus 3, it's 43. I think this is the input we are waiting for. Yes. So if I press enter, I should write the following thing. The sum of 25, 15, 3 is 43. Okay, but separated by commas. It should work for any string, not only with three digits, 3 numbers. So I can give like 40, 2, 15, 71, This is it. So the sum of all of these numbers is this much. How am I going to do this stuff? We have the function here. You're not going to write anything. I'm going to explain it. So, you remember from first class the functions find, the function find, what it was doing or not?
Yeah.
Nice. If you remember it, then we are using it here, you see? So I want to find a semicolon, and everything before everything which is before that semicolon is a number. I'm taking the number, okay, taking it away from the string, and I'm using the rest of the string as my input. So let me tell you first the algorithm here on board, how it works. And I'm going to go through the code step by step. So this is my, what was the name? My line, okay. Line should be given as an input. Let's say I'm giving 35, semicolon 25, semicolon 3. This is my input. I have another variable which is called number here. You'll see how they are used here, and you'll see the coding stuff. I have so this is also string. Line, of course, is string. Then I have index. I have another variable which is called length. Maybe I'm going to play the role of the compiler at this particular example, because it looks like it's harder, but it's not. It's important to understand how we do the coding stuff behind. And we have, okay, so this is integer. The length is integer. We will see what we are talking about. We have another integer, which is the number. And another one, the sum. Okay, so I'm reading the line. Let's say that gave these guys an input. And I want to find the length of this line. What's the length of this line? This is a string. That's why I'm going to put it in quotation marks. The length is how much? Come on. Are you sure? 1, 2, 3, 4, 5, 6, 7. Yeah, the length is 7. So I have 7 here. Then I want to find the first occurrence of semicolon. And I find it, and I put it here. It's 0, 1, 2. Index is 2. I found the first occurrence, okay? Better let's see both the code and here on board what's going on. From scratch, again, I'm defining string, line and number, an index and the length, number, sum. This number is going to be this number converted from string to integer. We're going to use the toy function we already saw. The sum is initially 0. We saw it in the previous example. So now I'm printing this stuff here. So all the memory is reserved. I mean, in RAM we have boxes. We reserved memory for this stuff here. Now you are going to see the output as well. So I'm printing this line. Enter string of numbers. Enter string of numbers. Now let's say that I give these guys an input. So 35, semicolon 25, semicolon 3. And I press enter, and it goes here. This is done with this line here. Now I'm printing the sum of Now I'm taking the length, line point length. The length of this guy is 7. We put it here. Now we want to find the index of the occurrence of semicolon. So index is equal to line point find. So line is this value. Find what's the index is 2, because 0 we start always from 0. This is 0. This is 1. This is 2. This is 6. Yeah, the length is 7. But since we start counting from 0, this guy is 6. So where does semicolon occur? At index 2. Very nice. Then we go to this while loop, which is going to repeat it again and again. We are asking the following thing. Index is not equal to no position. This is true. No position usually is a very big number, or no position is returned when something is not found. Okay? But we found index is 2. So 2 is not equal to one position. Yeah, this is true. That's why you go inside. And we say that the number is equal to line point substring from 0 to index. We start from index 0 and we go up to we are taking index number of characters. So let's see what we are doing. This is line. We start from 0 and we take 2 characters, because index is how much? Index is 2. We take 2 characters, so meaning that this is 35, and substring is going to return a string which is 35. Now this is going to be put to the number. Okay, did you understand this one? So we start from index 0, and we are taking index characters from that string. Our index is 2, so we are taking 2 characters starting from 0, meaning we are taking 1, 3, and 5. It makes 2 characters. We are putting it here. We have 35. We go here. Num is equal to atoi. String to integer, and number is a string. We are converting these two, but this string, this 35 here, to 35, which is integer. It's a string here, it's going to be integer here. We saw that this function is defined in the string utilities library. Okay. Is this clear so far? Yes or no? Yes? Did you understand this part? All of you, please raise your hand. Who understood it? Yeah. What about you guys? Ilhan, you? Did you understand this?
Yeah.
Okay. If you didn't understand it, please stop me. So, we converted this string to the number. We are now finding the sum. Sum is equal to old sum plus this number. The old sum initially was 0, initialized to 0 because it's a sum. So the sum is equal to 0 plus 35. This is going to be 35. We go here, we print num, the sum of, so we have 35. Then we print the comma. We print the comma here. We go to this line here. I mean, you have the columns, the comments here. Each line, what is each line doing? Now we say the following. Line, this variable here, is equal to line substring of index plus 1 to the length. Let's see what are we doing. First, let's find the value of this guy here. Line substring index plus 1 length. Index plus 1, index is 2. Index plus 1 is how much? 3. So this guy here is 3. We start from 3 and we go till the end. Okay? The length is 7. So we start from 3 and we are going to take 7 characters. But you might say, okay, we have here only 1, 2, 3, 4 characters left. If the number of the characters we want to take is higher, is bigger than the number of characters left, then we go to the end. It's not a mistake. Okay, we have 4 characters. We want to take 1,000, but I'm sorry, you have only 4. You'll take those 4. Okay, so again, subline point substring index plus 1, 2 plus 1 to the length. This part here is basically going to return this string here, 25 semicolon 3. It's going to be returned And all this string is going to be assigned to line. So it's a kind of, this stuff here is erased, and line now is this string. Now this is the 0th character, this is the first, this is the second, and this is the third or the last. We go to this command now. The new index is equal to line point find. Now let's see. Do we have semicolon? Yes, we have. It's here. It's in this index number 2. That's why the new index will be, the old index is going to be erased. Find is going to return 2 because it's here, the semicolon, and the index will be 2. Now, since we are dealing with a while loop, we go up in again here, and we are asking, index is not equal to n position. So this 2 is not equal to n position. This is true. Because this is true, we are going inside. We are taking the number again. It's substring from 0 to index again. We start from 0, and we take index characters. We start from 0 and we take 2 characters. So basically it's 25. So string number now is going to be 25. We are converting this number from string to integer and put it to number. So this num will be 25, but as an integer, not as a string. Again, we're finding the new sum. So we are saying the old sum, the new sum is equal to the new old sum plus number. The old sum is 35, plus number is 25, so what do we have? It's 60, so it's put to 60. We have 60 here. We go, we print the num and the comma. So we print 25, comma. We take the substring of the line from index plus 1 till the end. Index plus 1 is 2. 2 plus 1 is 3. So from 3, length is 7. We take 7 characters, but hey, we don't have 7 characters, we have only 1. We are going to take only 8. So this is going to be taken, returned from the substring function. Only 3 is going to be returned, and this 3 as a string is going to be assigned to line itself. So this stuff is going to be erased. We have 3 here as a character. And this is the only index. This is index 0. We go to the last line. Index is equal to line point find. Now this is an important thing. We want to find semicolon in a string that has only 1 character. This is 3. Is it going to be found? No. When we don't find semicolon, this pattern here, it's going to return something that we call n position. So index will have n pos here now, finally. Usually this is, as I told you, a big number, very big number, or negative number, depending from compiler to compiler. I think in Visual Studio, it's 2 to the power of 32. But I'm not sure. I think it's like that. So we have no position because it's not found. Now we go to while again. We are asking index, which is no position, is not equal to no position. Is this true? No position is not equal to no position. Is this true? No, it's false. That's why we are not going to execute this block. We are continuing immediately after it. What do we have after that? We have the following stuff. That if you don't find the semicolon, basically what is left is another number. And we are converting this number using a toy function, string to integer. That's why it stays for a toy. A you can think as a string, a name of a string. To I to integer. And as a parameter it takes the line. So line is 3. To num we put 3, but as integer. Okay? We are finding the sum again. The new sum is equal to the old sum plus the number. So it's equal to 60 plus 3. The sum is 63. And we are printing the num is, so 35, 25, num is 3, we're printing the sum in the end, 63. This is the end of the function, okay? If you understood this one, it will be very easy for you to deal with a find function. Let me see whether we get this. I mean, this is how the compiler is working. I intentionally played the role of the compiler on board. We could have used step over, step into, but I just wanted to go myself through those issues. Let me run the program again. So, enter string of numbers. I'm giving 35, semicolon, 25, semicolon, 3. The sum of 35, 25, 3 is 63, just as we saw it here. Okay? Questions? No questions. Nice. Let's go with another function, another piece of code, which is called pattern search. We are going to keep the string utilities library. Just remove the toy function. You saw an example of using one of the functions of the string utilities. You're going to use maybe all of them or many of them. So just add the pattern search. Add existing item, pattern search. This is it. Okay. Let's see what this guy is doing. This function is counting the number of smileys in your string and printing that number, of course. So let me check it. It has two functions. We are using only one of them. We don't have time to deal with both of them. Let's see just the output. Okay, enter the input string. ARTRIM, smiley, hello, smiley, smiley, full stop. How many smileys do we have here? 3. And this guy should return this stuff. Number of smileys in the given string, blah, 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 is 3. Okay, this is one smiley, another one, 3. Okay? We can do something like this. Now we have 2 smileys, and so on. Let's see how this stuff is done. Again, I'm going to play the compiler here because it's important. Not going to use step over function. It's going to be something similar to this one, but not exactly. This is going to be our output, as it is seen in the prompt, command prompt, at the console. So let's see, what do we have? We have the main, we have the input string, the one with the smileys. We are prompting the user to enter the input string, we are reading it. Then we say the number of smileys in the given string is, and we are calling a function which is called find smileys in order to print the number of smileys. So let's see what find smileys is doing. This is our function, find smileys. It returns an integer value, which is the number of smileys, and as a parameter it takes an input string. Okay? It has the following variables here. Number of smileys is initially 0, index 0, length 0, and the search pattern is a smiley, of course. Okay? So I think you will understand better this function if I go step by step. I'm going to, okay, let's go from main and then let's play the compiler basically. So main, in main, we have the input string. We're defining a string which is of type, a string of a variable of type string. It's called input string. We are printing this stuff, enter the input string. Again, I'm playing the compiler, okay, so pay attention. So we are printing enter the input string. Now I am giving it, let's say that the input string is the following. You can give me your string, come on. That has smileys, 2 or 3, whatever. Come on. Okay, let's say this is our input string. AR, smiley, we don't have any space here. TR, smiley. I am, smiley. We have 3 smileys. So this is our input string, and this is going to be put here. AR, smiley, TR, smiley, I am, smiley. I am putting it in quotation marks, so you can see that we are talking about a smiley here. Okay. So I've read it, I've put it into the variable, and I'm printing this stuff. Number of smileys in the given string. So number, blah, 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 is and I'm calling the function find smileys and sending this input string as a parameter. So let's see what find smileys is doing. This is the function. So here we are in the function find smileys. It doesn't take any reference, it's just taking a parameter, find smileys, yeah. Okay, here we have this input string, but this input string is called in the find smileys function as input string, literally. So basically we are sending a copy to this guy. So we have AR, no empty spaces, smiley, TR, smiley, I am, smiley. We are defining few variables here, the 3 of unsigned integers. We have a variable which is called smileys. Basically, we keep the number of smileys here. Initially, it's 0. We don't have, we start counting from 0. Index, the appearance of the first smiley, initially is 0. We don't know. And length, this is for the length of the input string. Length, it will be 0, but we are going to assign the length of this string to the length. Search pattern is the following. So we have search pattern it's a smiley because we are looking for smileys. This is the pattern we are trying to find in the input string. Okay, initially it's smiley. So the length is the input string point length. Let's see what's the length of this guy. Here we have how many characters? This is 0, this is 1, semicolon 2, brackets, parentheses 3, and so on, 4, 5, 6, 7, 8, 9, 10, 11, meaning so the index of this guy is 11 of the last closed brackets of the last parenthesis. So what's the length of the string? It's 12. Okay. Length is 12. Now we are asking So this is the loop that we are going to repeat again and again. Basically, we find the pattern. If we find the search pattern, smiley, we are increasing the number of smileys and taking, this is what we're doing. We find the smiley, yes, very nice. Increase the number of smileys here, remove this part of string. Again, find the smiley, increase the number, remove this part of string, and so on. This is done with this while loop. If index is smaller than length, index is 0 initially, smaller than 12, this is true. We are going inside, and the index now is the input street find search pattern index. What does this mean? Search pattern is this one, okay? So I forgot to tell you about another function. We saw find. The function find that we previously saw takes only one parameter, and that's the search parameter, okay? And it starts searching the string from 0, from index 0. But sometimes you might say, okay, I know that in the beginning I have a smiley, but I want to know whether I have the smiley after the 5th character, okay? So you give the smiley here, you give the index, meaning that if index is 5, I start searching from 5 and on till the end. Okay, this is the difference between find with one parameter and find with index. So find with one parameter, only the search pattern, let's say smiley, it starts always from 0. While this find here starts from the index we're sending as parameter. Okay, yeah, in this case it's 0, but we just wanted to show you how the second find function works. This is called function overloading. You will see it, I think, in CS204. You'll be dealing more with those functions. Basically, overloaded functions are those functions that have the same name, but the parameters are different. The parameters that the function takes are different. Not the number of parameters, even the type of the parameters, okay? So, what we are saying with this function here, I want to find the search pattern, basically it's actually the smiley, starting from the 0th index, from start. And do we have it? Yes. Where does it start from? It starts from 2. That's why this guy is going to return 2, and 2 is going to be assigned to index. So index is now 2. Now, if the index is not equal to n position, 2 is not equal to n position, we go inside. I'm saying that the index is equal to search pattern plus length. Okay. Search pattern length. What's the length of search pattern? 2. What I'm saying, the new index, so this index plus means index is equal to index plus search pattern length. Search pattern length is 2. Plus 2, it's going to be 4. So we have 4 here, because the old value, basically we're writing that, okay, the old value is equal, the new value is equal to the old value plus the length of the search pattern string. The old value was 2, the search pattern length is 2, so the new index is 4, and we increment the number of smileys by 1. So smileys initially was 0, but hey, we found one smiley, we incremented it by 1. Now you might ask, why do we need this index 4 here? Can you see why? Because we found it here. Now we are starting from the 4th index, which is 4, until the end. Again, this guy is finished. Now, since this is a while loop, we go here. Index is smaller than length. Index is 4, length is 12. This is true. We go inside. The new value of the index is equal to search pattern. Find this guy starting from index 4. You see why we use this find function? We don't want to change the string. Okay, I thought this was deleting the strings, but no, we're not touching the string. We're just moving with indexes. So I want to find the smiley starting from index 4, because previously I found it once. So starting from 4, do I have another smiley here? Yes. At which index? 4, 5, 6. Because those two semicolons are at index 6. Yes, this is going to be returned to the index. We have 6 here. So the index is 6. And I'm asking, 6 is not equal to no position, no, not found. This is true. Then I increment the number of index by search length. So 6 plus 2, the search pattern length, it's going to be 8. So 6, 7, 8. This is 8. Basically, we start searching from 8 and until the end. And I increment the number of smileys. I found 2 smileys till now. Again, is index smaller than length? 8 is smaller than 12? Yes. We go. We want to find the search pattern, the smiley, starting from 8. Which is the next occurrence? Which index is this one? 10. That's why index will be 10. So this is 10. 10 is not equal to no position. This is true. That's why I'm incrementing the index to be great, plus 2. Search pattern length is 2, plus 2. This is going to be 12. Increment the number of smileys by 1, because we found 1. This one. 3. Now we go in the beginning. 12 is smaller than 12. Is this true? No. That's why I'm returning the smileys. This return will go to this integer here. Basically, when I'm returning the number of smileys, it will be here instead of the find smileys function. So I'm going to print 3. Number of smileys in the string blah 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 is 3, and I'm going to a new line. This is the function and the program. Okay? Questions? Do you want a break of 3 minutes?
Yes.
Okay. We will be back after the break.